In this video, we're going to be talking about rational functions, and specifically, we're going to be talking about asymptotes of rational functions. So there's three kinds of asymptotes we're going to talk about. Vertical asymptotes, which means it's restrictions on the denominator. We know that you can't divide by zero in math, so we find out what numbers makes the denominator turn into zero. We're also going to talk about horizontal asymptotes, and we've got this Bobo bot needs DC, and we'll cover that a little, but Bobo means if the exponents are bigger on bottom, that's equal to zero. Bottom means bigger on top, and that means it has no horizontal asymptotes, so none. Bigger on top, none. And then eats DC, if the exponents, the biggest exponents on top and bottom are the same, then you divide the coefficients in front of those variables to get your horizontal asymptote. Now, slant asymptotes is going to happen when it's bigger on top, like it doesn't have the horizontal asymptote, so it's bigger on top. And we'll discuss how to do that. All right, so let's look at our first example. We have 5 over 2x minus 9. Okay, so the first thing I'm going to do is talk about the vertical asymptote. And I'm just going to use the initials VA or HA or OA for oblique asymptotes. Okay, so for vertical asymptotes, we're going to set the denominator equal to 0 and solve. So if I move that 9 over, I get 2x equals 9. And then divide by 2, I get x equals 9 over 2. Okay, so that is going to be a spot on the graph at x equals 9 over 2 that the graph will not cross. Okay, we put a dotted line there, and the graph would get infinitely close on either side of x equals 9 over 2, but it won't actually cross that. Okay, now let's look at horizontal asymptotes. So we go up here and it says Bobo bot meets DC, bigger on bottom. We're talking about exponents. So since there's no variable in the top at all, so the biggest exponent is this 1 right here on this x on bottom. Okay, so this is bigger on bottom. So we automatically know that our answer for horizontal asymptote is y equals 0. So if the exponent on bottom is bigger than the one on top, you get y equals 0. Okay, and a horizontal asymptote you can cross, unlike a vertical asymptote. Vertical asymptote you absolutely can't cross because you'd be dividing by 0 if you did. But a horizontal asymptote is more of a guideline. As you go out to infinity and negative infinity, your graph is going to get closer and closer to y equals 0, which is the x-axis. Okay, this does not have a slant asymptote because if it has a horizontal asymptote, it doesn't have a slant asymptote. If we don't have a horizontal asymptote, then we do have a slant asymptote. So these are your two, and I'll just graph one real quick. I'm not going to graph the function, but just what the asymptotes would look like. So if we go, let's see this, 1, 2, 3, 4. 9 over 2 is 4.5, so it's somewhere right in between 4 and 5. So that would be a dotted line that we put right there at 9 over 2, and the graph would go up against this line and maybe go up or maybe go down on either side. Maybe go up here but not cross, or down here and not cross. And your horizontal asymptote, of course, is right on this axis at y equals 0. So that's more of a guideline as you go out towards infinity and negative infinity. Okay, so that's it on that problem. Let's look at the next one. F of x is equal to 10x minus 13 divided by negative 4x plus 10. Okay, so for our vertical asymptote, we'll set the bottom equal to 0 and solve. Okay, move the 10 over, you get negative 4x equals negative 10, and x is equal to negative 10 over negative 4. Reduce that and make it positive because you're dividing by a negative, and it's already negative, so it's 5 over 2. Okay. As far as your horizontal asymptotes, it looks like the biggest exponent on top is a 1, and the biggest exponent on the bottom is 1. So exponents are the same. We're going to divide the leading coefficients. So I'm going to say y is equal to 10 over negative 4. Those are the leading coefficients out in front of x. Okay, and that's going to reduce to negative 5 over 2. So our HA, horizontal asymptote, is y equals negative 5 over 2. Okay. Let's look at this problem. We've got negative 2x minus 5 over x minus 4. My vertical asymptote, x minus 4 equals 0, so it's going to be x equals 4. And my horizontal asymptote, it looks like the exponents are the same. So my HA, horizontal asymptote, is going to be y equals negative 2 over 1, which is just y equals negative 2. And that's it. Looking at the next problem, it looks like we got a quadratic here on top and on bottom. So to find the vertical asymptote, I'm going to set the bottom equals 0. That's negative x squared plus 4 equals 0. Move the 4 over so you get negative x squared equals negative 4. Multiply both sides by negative 1 to make them both positive. So x squared equals 4. And then do the square root of both sides. Make sure you put a plus and a minus right there. Okay, so plus or minus square root of 4. So x is equal to 2 and negative 2. Okay, plus or minus 2. So we have two vertical asymptotes on that particular problem. All right, and the horizontal asymptote, looks like the biggest exponent on top and bottom is a 2. So the leading coefficient is 3, and there's a negative 1 here. So y is equal to 3 over negative 1, which is just y equals negative 3. Okay, let's look at the next one. So vertical asymptote, looks like we got a quadratic here we need to solve. So for the VA, 2x squared minus 4x plus 2 equals 0. I'm going to divide everything by 0, or not by 0, everything by 2. So every term, including the 0, I'm going to divide by 2 on both sides. Okay, and that will give me x squared minus 2x plus 1 equals 0. So I'm going to have to factor this using the AC method. So you multiply the first and the last term, that gives you a 1. We need factors that multiply to 1, but add to get negative 2. That's going to be negative 1 and negative 1. You multiply those together, you get 1. You add them together, you get negative 2. So this becomes x minus 1 times x minus 1, which is just x minus 1 squared. We only need to solve one of those because they're the same. So we get x is equal to 1 is our vertical asymptote. Okay, for our horizontal asymptote, it looks like it's bigger on bottom, right? This is a 1 and this is a 2, so it's bigger on bottom. So if it's bigger on bottom, it's 0, so y equals 0. Okay, let's look at this problem here. So we've got a quadratic on both top and bottom again. So I'm going to set the bottom equal to 0 to find my vertical asymptote. So that's 2x squared equals negative 9, and that's x squared is equal to negative 9 over 2. Okay, so if I square root both sides like I did over here, I'll be square rooting a negative number, and that's going to start involving an imaginary number, a complex number. So we can't do this in real numbers. It's not going to give a real solution. So I'm going to say there are no vertical asymptotes because that gives a non-real solution. Horizontal asymptote looks like the exponents are the same, so I divide the coefficients. Y is equal to 1 on top and 2 on bottom, so y is equal to 1/2. Okay, last two. So looks like this time we've got just the x plus 3 on bottom. So x plus 3 equals 0. That means x is equal to negative 3 for our vertical asymptote. Since the exponent's bigger on top, let's go back and look at our rules because we haven't done one of those yet. If it's bigger on top, that's no horizontal asymptotes, but then you have the slant or oblique asymptotes. I like saying oblique asymptotes, so I'm going to use that. What we're going to do is we're going to use long division, and we're going to divide the numerator into, or the denominator into the numerator. So x plus 3 out front, and then on the inside we have x squared plus 7x minus 3. So what do I multiply x by to get x squared? It would be an x. So x times x is x squared, and then x times 3 is 3x. Okay, subtract, or change the sign. I circle them so I can remember that I've changed the sign. Okay, so this one goes away as it should. And then 7x minus 3x, it kind of looks like an 8 there, but that is a 3. 7x minus 3x is a 4x. Drop down your next term. Do it again. What do I multiply x by to get 4x? 4. Okay, and at this point, you don't really have to go any farther because your slant asymptote is just this right here, x plus 4. Okay, but if you wanted to finish it up, it would look like this. 4 times x is 4x, 4 times 3 is 12. Subtract and subtract, so you get negative 15. But again, that for this particular problem, the remainder doesn't really matter to us. Not going to explain why. That's more of a calculus concept, but I will say that as you go out towards infinity, this term, this remainder over the initial divisor would eventually go to 0, so it doesn't matter. So our oblique asymptote is going to be y equals x plus 4. Okay, so on a graph this one since we haven't seen one of those again. This oblique asymptote, would cross at 4, 1, 2, 3, 4, and it would have a slope of 1. Okay, so that should be a dotted line, honestly. But this would be what the asymptote would look like. So the graph would kind of go up against it like this and go up against it like this or something to that effect. Okay. So let's look at the last problem. It looks like we've got the same sort of deal here. So vertical asymptotes at the bottom equal to 0. And we get, let's see, 2x equals -3. X is equal to -3/2. So that's vertical asymptote. The exponents on top are bigger, so we have none on the horizontal asymptote, which means we have an oblique asymptote. So I'm going to use long division again. So I'm going to divide in 2x plus 3 into 6x squared plus 5x minus 4. Okay, so as I multiply this, what do I need to multiply to get 6x if I have a 2x? So that's going to be 3x. 3x times 2x gives 6x squared. So 6x squared, and 3x times 3 is 9x. Subtract and subtract. Okay, and let's see, this one goes away. This one turns into -4x. Drop your next term. Do it again. What do I multiply 2x by to get -4x? It's -2. And we know we don't have to keep going, but I'll keep going anyways, just to do it, finish up the problem. So that's -4x, and it would be a -6. Okay, change the sign. They're both negative, so make them positive. And that's going to give you a remainder of 2. But again, that doesn't matter. Our oblique asymptote is y is equal to 3x minus 2.